issue with our bilge pump. It's been with the boat since we bought it. There's an automatic bilge pump, electric bilge pump, but it doesn't work properly because when it's on the automatic setting, if the bilge breaker is on, it just runs constantly. And of course, this I'm almost positive has to do with a missing or failed or something sensor, the trip switch that turns it on and off. So the first thing I did this a few minutes ago, so I already know the answer, is I pulled this panel out. Here's our Jabsco automatic bilge pump, and I look back here and I see a whole bunch of wiring, and just looking at that, I know that it was wired properly. That's not the issue, and I doubt seriously if it's the pump either. Here, I'll kind of turn this on to show you what I'm talking about. If I go in here, gosh, where's my bilge pump? I only do it all the time, and then I can't see it. Bilge pump, there it is. Okay, so if I turn this on, you can just hear it running down there. You know, doesn't really matter. Even when it's on the off, it's still running. The only way to turn it off is to turn the breaker. Actually, switch the breaker off. That's clearly not the way it's supposed to be. This boat takes on almost no water, but that lulls you into a false sense of security, where you just kind of don't check and everything else. And you know, if a seacock or one of the black water pipes or something was to come undone, this boat could take on a lot of water really fast, and you really wouldn't know it until it started coming up above the floorboards. And that's by that time you've done a lot of damage. Salt water will have gotten into the wiring systems. The batteries could potentially go underwater. If that happens, you know, then you lose your pump. You can't start your engine. There's a disaster happens very, very quickly. So we're working at trying to figure this out. I look down into the bilge, and what I see is this wire and that brown wire running down into the bilge with a loom around it, with a clear spiral loom. And I'm almost positive that that's the switch. And as you can see, the wire goes straight into the water, and that means the switch is underwater, and the whole thing isn't working the way it should. I think that these two flathead screws at the top of that piece of plywood will disassemble this whole thing and allow me to take the plywood itself up and out. And that's what I'm going to do. I'm going to start by hitting it there and seeing where it leads. I'm going to disconnect these spade connectors and I'll also clip that zip tie. Okay, so now I've disconnected these two. They're actually bullet connectors, as you can see. So that should disconnect the switch and open that circuit. So let's go give it a quick test. Let's see what happens. This is on automatic. Bilge pump gets turned on. Nope, still running. Off. Let's try that. Nope. So it's possible that these are meant to be closed, and the only way I can really do that is to make myself a small bridge, which I think I'll do. It's worth figuring out how the system works. So after a lot of gnashing of teeth and everything else, this is the float switch for the bilge alarm, and as you can see, it's basically been way underwater from the line there. And part of the problem there is that our bilge pump does not, the pickup is not is not that high. It's in another area of the bilge, and it's a little higher up. And so this is the typical water level. So at the minimum, I'm going to have to raise this up some, but I need to check first to make sure that it works. Let's start by running this over to ohms. It says 1 when there's no continuity and 0 when there is. So what we'll do here is we'll check this part first. No continuity. That's good. Lift the float. We've got 0.5 ohms. That's good. So this comes up. There, everything's good. Now that brings us back to the other problem, which was even with this thing detached, the bilge pump was still running when turned on. So this part is functional, but I'm thinking that there's a wiring problem someplace else in the bilge system. I'll have to chase after that now. Down here, I've got a little speaker on a 9-volt battery that allows me to see continuity in the power supply to this little Maxi Puppy 3000 electric bilge pump, which we have a spare of, which is an important thing. Make sure this is really our primary bilge pump, and we don't want to have this fail and then suddenly not have a bilge pump. So we've got a spare for that. We've disconnected the entire switch. We've taken every wire off of it, and yet we still have a situation where if the bilge pump breaker is turned on, the pump will run. And I've got this LED light down in here attached to the power for the bilge pump. I'm aware that we don't have a functional bilge pump right now, and this is not ideal, but we have to fix this problem, and we're not going to haul the boat in order to do this. The best thing to do is to do a job like this all the way through and make sure you remember how to get it wired back up real fast if you need to. Coming around to the back side of this partition, we have a Hella 20 amp 24 volt relay that says bilge pump on it, and it's got a whole bunch of wires coming into it. This relay may be bad, but I kind of doubt it. I think what happened was that someone trying to wire this got confused and eventually got to a place where they at least had a bilge pump, as long as they turned the breaker on, and they just went to full manual setting. We don't like that. In fact it's part of the requirements from the British Coast Guard that boats over 11 meters have all of these systems automated. So we're trying to get this thing back. Let's talk a little bit about what a relay is and what it does. So why would you use a relay? Why not just run a circuit that runs to the pump through the float switch and back? And the answer is that DC voltage drops significantly depending upon how far the run is. Now you can upgrade and take the cable diameter up higher to help work around that a little bit. But the real problem there is that you've just got a very long run of cable. Now it doesn't look very far, but I would estimate that there's probably a good 100 feet of wire between here and the bilge pump and the float switch. And if you can cut that number in half, you're doing yourself a favor. So the way a relay works is you've got two circuits running through it. One runs through a coil, which creates an electromagnet. It's used to close a secondary circuit. So you can view the relay as being a remote control switch. One circuit controls whether another circuit is open or closed. What this does is it allows the float switch with 24 volt power behind it to create the electromagnetic force to close the circuit that runs the bilge pump, thereby keeping basically keeping voltages steady to the pump, which is the really the most important thing. If you're running if we're on a 24 volt system, and which tests out typically at around 27 or 28 volts, if you're running a 24 volt pump on, say, 18 or 16 volts of power, it's gonna burn out eventually, and at least it'll accelerate that. So that failure. We don't want to have that happen with a bilge pump. So now it becomes a matter of pulling this apart, and I've already researched this relay from Hella to find out which pins do what, and I'm gonna basically have to go through. I'm gonna start by labeling this as being like 1 and 1 and 2 and 2 and 3 and 3 and 4 and 4 around, again in the interest of being able to throw this thing back together as it was done before, and get myself a working bilge pump should an emergency arise. I've also gone and documented what the relay looks like and how it's done, and also the switch itself, the toggle switch, to make sure that I have a full understanding of how these switches and relays work. People ask all the time, what's your most important tool that you have on the boat in your toolbox? And I would say I use my electrical meter, and I've got two of them. I've got two high-end GB and Klein tools voltmeters and digital voltmeters, and those are just absolutely the most important thing for diagnosing problems on boats, and electrical problems are the hardest. They just are. That physically, plumbing problems are harder and nastier, but electrical problems are more common, and you just, seems like hardly a day goes by where I'm not just checking something. So what I'm doing right now is I'm going through and doing the simple stuff first and just double checking. So to make sure that this bilge pump switch is actually the breaker that's controlling the power to the bilge. And so I've got it off, and there's no light on right now. Turn it on, we have light down there. So I've started my problem solving with the simplest side, making sure that I'm not working on the wrong circuit. It sounds stupid, but you really need to go through these things on a step-by-step basis. I should add that putting this light on here is not just about me seeing if there's power there and helping the pump by not running it dry. It's also necessary that there be a load on a circuit, or else the circuit breaker is going to see that as a short. I don't know what the sensitivity of the breakers are as far as what type of a minimum load it needs, but an LED light like this doesn't draw very much power, but it does have some resistance into the circuit, and therefore accomplishes what we're trying to do. I've checked the float valve to make sure that it functions. That that when there's water rising, it's underwater, that the switch actually does come on.
What's Kevin doing? I think he's playing with the bilge pump one more time.
Yeah, trying to get a piece of plastic out of here that, honestly, the Chinese decided in their infinite wisdom to put two pointy pieces to destroy your fingers while you try to use this thing. There's no getting your American-sized fingers in. Just absolutely impossible to use this tool And of course it's not working because the piece floats away. I just don't know how to get it out. The original pickup location was over here, very close to the bilge pump. But the actual switch, bilge switch, which is pretty difficult to relocate, it's factory installed kind of down below the battery box. And the problem we've had is that if the boat's rolling, water sloshes to the front, activates the switch, the pump runs, but then the pickup doesn't it draws air because they're far apart. And it even says in the rule bilge float switch manual that the pickup has to be really right next to the switch. So that's what I'm trying to do right now, is relocate the pickup. This is the deeper part of the bilge anyway, and it really ought to be over here. And probably was at one time, but somebody along the way moved it. We're not going to burn everything up or drop it in the water. It would suck. There we go. A lot easier. So the idea here is just to run it really long until we get it to the pump, and then cut it to size. It's going to need another couple of opposing clamps, hose clamps on the other end as well. There's no project that we do on this boat that ever goes easily. There's always some sort of a problem. We got our new pickup location. I already tested this, but Wendy's going to run it again just to make sure that we get it all. Yep. So there we are. That's the bottom of the bilge, and we can actually see our keel bolts now, which we really weren't able to before. And this is a much better deal. It's always nice to have new piping on this stuff anyway.